All right. So if data is approximately normally distributed, for example, freeway speeds, if driving down the freeway, the average speed is 65 miles per hour, I put 65 in the middle, you're going to have 4 or 5 opportunities to draw this normal distribution curve today. We put the mean in the middle, and if the data is normally distributed, usually we use capital N to represent the mean and the standard deviation for a population. So if this data is normally distributed with mean 65 and a standard deviation of 5, this is in miles per hour for speeds on the freeway. Then I'm going to add and subtract 5 from 65. 65, 70, 75. 3 standard deviations would be 80 miles per hour. And it's possible to be more than 3. For example, somebody driving 82 miles per hour on the freeway is more than 3 deviations above average. Same thing going the other way, subtract 5. So these numbers 0, 1, 2, 3, -1, -2, -3, those numbers are in terms of Z. Those are Z scores. The numbers underneath are in terms of miles per hour. That's called X. So like in algebra, we use X as a generic variable. That variable X represents speed on the freeway, miles per hour. So we're going to use the empirical rule, and 68% is the rule of thumb. Notice the numbers that are given, 0.3413 and 0.3413, that's 0.6826, 0.6826. That is a number that is the actual number for data that's 1 deviation away from the mean. But the rule of thumb says 68% of data is 2 deviations. Or I'm sorry, 1 deviation. So 68% represents a speed of between 60 and 70 miles per hour. 68% of cars on the freeway are driving between 60 and 70 miles per hour using this data. 95% of cars will drive between 55 and 75 miles per hour. That's most cars on the freeway. Okay, there's some cars that will drive faster than that, some cars that will drive slower than that, but this rule of thumb given this mean and standard deviation. So any data that's approximately normally distributed will follow that distribution. And 99.7, that's almost all cars. That's 50 to 80, 99.7, 50 to 80 miles per hour. The bells are having problems today. Interesting. All right. So that's a normal distribution curve representing 68, 95, 99.7% of data. So if the middle is where the mean goes, the spread, if you have large spread, if standard deviation is large, you have a small flat curve. Standard deviation is small, you have a skinny upright curve. But the bottom right red one shows standard deviation represented as a -1, -1, and -2. These should be negative numbers, -2 and -3. That's a typical standard normal distribution. So we call it the standard normal curve. I wrote examples of normal curves, but usually you'll see the word standard in there. And I've been using that language the last 2 weeks. If you're going to standardize, you're going to find the z-score. So again, those values are called z-scores. Those standard normal curves, we'll use the standard normal distribution curve in the back of the textbook to come up with some of these values. All right. Let me go to my view, so I'm not showing your view. Find the mean and standard deviation for this data set. So what we would do is take the data and put it into a list in our calculator and draw the normal distribution curve for these are test scores for like a quiz or something, right? We want to find the average test score and say, is the data approximately normally distributed? So I'm going to enter the data into a list in my calculator. So go to your calculator. If you haven't used it before, I'm going to walk you through it. So on the calculator, press stat, and then press enter, and then press enter. And that's going to be edit a list, and you're going to see L1, L2, L3 for your list. So we're going to enter the data into list 1. So go to list 1 and enter 11, 16, 17, 17, 18, 19, and so on. There's 21 numbers, so we want to make sure we enter the data into the list properly. And then after you enter the data into the list, you're going to press stat, go to the right to calculate. C-A-L-C is calculate. We're going to do a calculation. Press enter for one variable stats. Number 1 is one variable stats. So we want one variable stats for list 1. We entered the data into list 1. And then we'll get the mean and standard deviation. So you should get the mean is 19.67. I want to round it to 19.7. And we use S. This is sample data, so these are like sample test scores. So we use SX. 3.08. There's your mean and your standard deviation. And we want to make a normal curve like I did in the first one. So like I said, you're going to have a lot of opportunities to do this. Hopefully you have plenty of room in your notes to be able to take notes on normal distributions. So we're going to draw the curve. And do your best to draw a curve. It goes up, goes back down, spreads out. And notice that it doesn't touch the line. Our curve does not touch the line. And then I'm going to put 1, 2, and 3 standard deviations on there. So right in the middle is your mean. And then the first inflection point, the graph is curving down, and then curves back up. So I'm going to put right on that point is one inflection point. Okay. What's going on with these bells? 3 deviations. And notice the gap is about the same for each of those. So I'm going to put in my mean right in the middle. 19.7. I'm going to put 19.7 in the middle. I'm going to estimate the standard deviation about 3, just so I can avoid the decimal places. I don't have enough room for that. So 19.7 plus 3 is 22.7. And then we add 3. And then we add 3. Customarily, we'll go out to 2 standard deviations, which is considered normal. Then I subtract 3. I go in the negative direction, 16.7. And 13.7. And finally, 10.7. All right, 95% of data, I'm going to shade 95% if I can. Wow, that's terrible shading. Let me see if I can use my eraser to erase all that. No. I'll try it one more time. Let me try this. Let me use my tools. Well, that is getting terrible too. Okay, 95% of data. Okay, so I'm shading 95%. That's 2 deviations away from the mean. So 13.7 to 25.7 is 2 deviations. %95 of data is considered normal or typical. A normal test score is 13.7 to 25.7. That's normal. Oops. All right, so look at our scores. 95% is from 13.7 to 25.7. 11 does not fall in that interval. 11 is outside the interval. So the basic method of calculating percentiles is the number of numbers and divide by the total. So the number of numbers that are in the interval, there's 25 numbers or 20 numbers in the interval. So 20 divided by 21 gives me about 0.95. So that just verifies, I'm just verifying the fact that 95% of numbers are in that interval. I think it's 20 divided by 21, 0.9523. Pretty darn close to 95% of our numbers are in that interval. All right. So now it's your turn. I have 3 algebra classes with a total of 65 students, pretty large sample size. Test scores are approximately normally distributed. The average score on the first test was a 64% standard deviation of 5. Draw a normal distribution curve. What percent are above 74? What percent are between 54 and 74? Is 82 abnormal? Find the z-score. So I'm gonna time you. I'm gonna give you about 4 minutes to work on this. So draw the curve, draw your bell-shaped curve, put the mean in the middle, 64, and then you're going to add 5, and you're going to subtract 5, and then calculate percentages. I saw there was a chat question, but can't get to it now. Yeah, I want you don't have to work. There's not much room on the on this page to work on Nearpod. So yeah, you can work on your paper for most of these problems. I trust that everyone is working, so I don't have to verify like with my Algebra 1 class. Whoa. Time's up. Ring the bell. Okay. All right, so we got a curve. I'm going to try to fit it in here. Let's see here. Put my curve on there. The more times you do it, the better you'll get at it. although that doesn't do very good justice to my drawing. Put 64 in the middle, and then you're going to add 5. Standard deviation is 5. 69, and add 5, 74. I typically will go out 2 deviations, subtract 5, and subtract 5, 54. So 2 deviations is normal or usual or typical. A typical grade for this class is a 54 to 74 if the average grade is 64. What percent are above 74? So this is something that the goal for today is to calculate this number as a percentage. What percent are above 74? Well, using the empirical rule, that's about 2.5%. Because over here is 2.5. Using the empirical rule, what percent scored between 54 and 74? That's 95%. If the middle is 95%, then we call it the tails. In the tails, what's left over is 5%. 1 minus 0.95 is 5%. 5 divided by 2 is 2.5 and 2.5. Is the score of 82 abnormal? Or where's 82 at? 82 is way above average. 82 is like way out here is 82. That's like more than 3 deviations away from the mean. So 82 is abnormal. We'll calculate the z-score. Z equals the x value. So we've calculated z-score plenty of times. So we take our x value, which is 82. 82 is x. Minus the mean. The mean is 64. And divide by standard deviation. So we do the numerator first and then denominator. We get 3.6. So a score of 82, 82% in the class. That's 3.6 standard deviations above average. And then what we'll do is we'll go to our calculator or our textbook to calculate that number as a percentile. What percentile is that? That's like the 99th percentile. Rarely will we ever say somebody's in the 100th percentile. It's like 0.999. Will we get to 100% for a percentile? Probably not. All right. More practice. Draw the normal curve. Once again, draw the normal curve. We're going to do this, like I said, 4 or 5 times so you get in the habit of being able to find areas under the curve. Does not touch, goes up like a roller coaster, bell-shaped curve. All right. Put the mean in the middle. Put 110 in the middle. And add 5. I'm modifying these questions because I don't like the questions when I wrote this. What percent are below 99? What percent are below 94? So whenever you're asked for a percentage, that means translate to a z-score, and then from z-score, calculate the percentile. So we're going to use our textbook, the table in the book. We'll also use our calculator to do these two things. So I'm going to calculate z-score. What percent are below 94? So 94 is like way over here. So what percent the area under the curve are below 94? So 94, again, way at below 100. I'm going to calculate that as a z-score. So I put in 94 minus the mean. The mean is 110. Divided by the standard deviation, which is 5. Calculate that real quick. And usually when I calculate z-score, I just do 95 minus 110, enter, and then divide by 5. So let's say ANS divided by 5. Hopefully you're following along. I got negative 3.2. So that value, 94, is 3.2 deviations below average. What percentile is that? What percent? So that's the question we want to answer. Z-score is not a percentage. Z-score just tells you these numbers are X values. And then as Z-scores, these numbers are -2, -1, 0, 1, and 2. So this 94 has a percentile of what? So we got 94. That's a z-score of -3.2. What percentile is that? 3.2. Go to T1 and T2 in the back of your book. So you go, it's way back there. There's notes, the N section. There's index, the I section. And then there's AP exams, tips, A section. So even after that, I bookmarked this page in the back of my book. Okay, so it's a bookmark section. One page you want to bookmark, T1 and T2. So T1, T1 and T2. This is the standard normal distribution table. All areas are given the area to the left, the standard normal probabilities, and they go out to 4 decimal places. So what I'm going to do is look for this number, -3.2. So identify, I hope you're in your book right now. Go to -3.20. Okay, at the top is the 0, 0, 0, 1, 0, 2. Z-scores always go out to 2 decimal places. I got 0.007. That's the percentile. So I don't write equal, -3.2 equals 0.007. That's bad notation. I would just write that is in the percentile. Percentile is a hard word to write with your mouse. Is 0.0007. There we go. Or that's as a if you're writing as a percentage, 0.07%. Okay, that's the area under the curve over here. Now, what percent are below 99? Again, we're going to calculate z-score. -99 minus 110 divided by 5. So 99 is like right over here, just below 100. What area is that represent? Negative 11 divided by 5 is negative 2.2. Look up that z-score as a percentile. So go into your book. Again, T1 is a negative z-score. Look up that number as a percentile. As a 4-digit decimal, negative 2.2 is 0.0139. Is 64 abnormal? Yeah, 64 is abnormal. 64 is unusual. 64 is way below average. Okay, more than 2 deviations below average. All right, now we're going to do this on our calculator. So we're going to get the same numbers on our calculator using normal CDF. So on the calculator, press second vars. And that takes you to distribution, D-I-S-T-R. This is called a normal distribution. So number 2 is normal CDF. So we got 4 things to enter. We got to enter the lower bound, upper bound, mean, and standard deviation. Now, with this normal distribution curve, we need a lower bound, so we need a number far smaller than 94. In the book, they use negative 1,000. In your calculator, you use, I think it's negative 1e raised to the negative 99th power or something like that. It's a really small number. But I'm going to do normal CDF for this calculation. On your calculator, hopefully you're following along. Normal CDF. The lower bound, I'm going to use a really small number, negative 100. Go up to, we stop at 94. We're going to go up to 94. The mean is 110. Standard deviation is 5. Equals. So let me do that. Again, we're going to have lots of opportunities to do this. Does anybody have Stat Wizard where it says lower, upper, mean, standard deviation? If that's the case, lower is just LB. So negative 1E99. Upper, I'm going to go to 94. The mean is 110. Standard deviation is 5. And notice 0 and 1 are the default values. 0.0. 0.0007. Okay, my calculator says 6.8 E negative 4. What is 6.8 E negative 4? Well, that is, as a decimal, 0.12368. And in our textbook only goes out to 4 decimal places in the table, so that's why it's rounded to 0.0007. So the calculator is actually more accurate. Normal CDF. Like I said, we're going to have plenty of opportunities to do this. 99, mean, standard deviation, 0.039. So all I got to do is change the 94 to a 99. 0.013903. Same thing. This also works if you did. We already calculated the z-score. So if you calculate the z-score, watch this: negative 100, negative 2.2. If I write it in terms of z-score, mean is 0, standard deviation is 1. Notice z-score is in terms of zeros and ones. So this is in terms of x. This is in terms of z-score. So we got x, we got z. We can calculate both. All right, a lot of good information there. Let's keep practicing. We got like 4 more of these to go through. In 2005, the SAT math test had a mean of 500 and standard deviation of 70. Draw a normal distribution of these scores. What is the range of scores 1 standard deviation away from the mean? What percent of scores were between 360 and 640? So again, draw a normal distribution. So you can do this on your paper. You don't have to do this on the Nearpod. Actually, you can't do it on the Nearpod. Draw the curve. What is the range of scores? So you're going to write that as parentheses. So 68% of data, and write it as an interval. This one gives the interval and it asks for a percent. Whenever you're asked to draw a normal distribution, you draw the curve, put the mean in the middle, then add 70, add 70. Should get it by now. What is it, 430? 500 minus 70 is 430. 500 plus 70 is 570. There you go. That's the answer to number 1. 1 deviation, 68%. Then add and subtract 70 once again. So if you subtract 70, you get 360. You add 70, you get 640. 95%. And then this one, what percent of scores are above 690? So we got to calculate z-score. So I'll walk you through this one again. Well, 640 is pretty high SAT score, 2 deviations. This is more than 2 deviations above average. Calculate the z-score. We would do the math. 19 divided by 7. I got 2.714, which is rounded 2.71. So I'm going to look that up. We looked up negative z-scores. So if I go to T2, again, I bookmarked this page. Got bookmarks. Here's my bookmark, just a plain piece of white paper, so I can flip to it pretty easily. I'm going to look up 2.71, and I see 2.71 is 0.9966. 0.9966 is the percentile. But that's not the answer. Not the answer. Because it says above. What scores are above 690? What percent of scores? So I gotta do 1 minus that. 1 minus 0.9966. 0.0034. So there's your solution, 0.0034. I looked it up. All right. Let's see here. I want to get into a little notation right now. So it says, what percent of scores were above 690? Here's notation. Probability X is greater than 690. That equals 1 minus probability X is less than 690. Again, we'll do this a few times so you can get used to notation. 1 minus, then I transform it into a z-score. So I did 690 minus the mean, and it was 2.71. So statistically, that's what you would have to do. That's all the math you would do. Or watch this. Here's where the calculator saves us. This is awesome. Normal CDF. Okay, what percent of scores are above 690? So 690 and above. 690 is the lower bound, and I need a number bigger than 690, so I'm gonna use like 1,000. You could use any number that's much bigger than 690. I wouldn't use like 700 or 800 because those values are pretty close. Use a big number. The mean is 500. Standard deviation is 70. You should get 0.0034. So second bars, normal CDF, lower bound 690, upper bound 1,000. Mean is 500. Standard deviation is 70. 0.00332. Okay, so it's pretty darn close. Maybe I should use a number bigger than 1,000. How about 5,000? Oh, it's the same answer. 0.00332099. All right, pretty darn close. 0.0034. And remember, I rounded 2.71. It was actually 2.714 in terms of z-score. So there's where you get some rounding error. So that number, a little bit bigger than what we would normally find. Practice, practice, practice. Practice makes perfect. All right, more practice. All right. I don't know what's going on with these bells. Is today minimum day? We wish. Minimum day schedule. Okay. When I was a student, I took the SAT my junior year. I got a 680 on the math, which is pretty good. I was good at math when I was a student, but I did really bad on English, so I wasn't that great of a student. 680 on math. So what is that number as a z-score? So if the sample or the population is normally distributed, so you'd write normally distributed with mean 500 and standard deviation 100 is the notation that you'll see, or you'll just be given the mean and standard deviation. I get a z-score of 1.8. What percentile is that? So 1.8 deviations above average. Use the table. So what percentile is a z-score? So you're taking one value and comparing it to everybody, all SAT score takers. And the SAT, different years has different scores. Different populations have different scores. So go to T2 and look up 1.80, 0.9641 using the chart. If you don't have the table, like yesterday somebody forgot their book. So I mentioned, okay, Google. Okay, go to Google and look up standard normal. Something happened there. I was trying to go to Google, and you just type in standard normal distribution table. And there's the table right there. It's the same table that's in the back of our book. You go to images and you can see they're all pretty much the same. They're just written a little bit differently. So we want to look up a z-score of 2.7.
We're not looking at the table. We select the Zoom.
Yeah, we can't see your screen. It says Zoom. It says Zoom screen.
Oh, I'm sharing my screen. How about now?
We can see it.
Oh, you can see it now? Okay.
Yeah.
So there's standard normal distribution table. Thank you for pointing that out. Can you see the Nearpod?
Yes.
Okay. All right. I'm not sure what happened there. All right. So let's say you scored a 620. What is your z-score? What is your percent? So I want you to calculate the z-score and calculate the percentage for a score of 620 using that same value, using 500 as the mean and 100 as standard deviation. Okay, so we actually have two methods for calculating this. 620 minus 500 is 120. 120 divided by 100. 1.2. Okay, so the z-score is 1.2. So I wrote it in terms of x, so I could go straight to the answer. If you scored a 620, what percentile is that? So we need a lower bound, a really small number. The upper bound is 620, the mean, standard deviation. If you write it in terms of z-score, so we write a really small negative z-score, go up to 1.2, the mean is 0, standard deviation is 1. And that's generic default values whenever you press second bars. If you have Stat Wizard turned on, those are the values you'll see. Those are SAT scores for the year that I took the SAT, 1994. That's when I took the SAT. That was a while ago. How many years is that? 26 years ago. Oh, geez. I'm old. All right. Given the mean SAT score for all UC freshmen, the average SAT score was 600 with standard deviation of 50. So much less spread for UC students. Make a normal curve, label each deviation. What percent of freshmen are between 500 and 700? Actually, you don't need to draw a curve for this one unless you already started. Just try to answer the question in about 30 seconds. I'll give you 30 seconds to answer using the empirical rule. Use the empirical rule. What percent is that? All right. 95%. 600 minus 50 minus 50, 500. 600 plus 50 plus 50, 700. That's 2 deviations. 2 deviations above, 2 deviations below, 95%. All right. So we didn't do much with using the table, but this is section T in the textbook, or if you want to Google standard normal table using the table, calculate these values. And notice some are greater than, some are less than. So I'm going to write the notation down on the computer, but see if you can use the table to find all of these values. All right, so notice the greater thans, those are 1 minus. So you look up the value and you do 1 minus that. Negative 1.15 is 0.1056. All right, cool. Use the calculators to find these values. Okay, so in the calculator, there's two methods. That's if you're given a mean or standard deviation. For this one, we're only given z-score. So I want less than negative 2.32. And the mean is 0, standard deviation is 1 because we're talking z-score. This one's greater than, so 1.3 is going to be your lower bound. So 1.3 is our lower bound, and we need a very, very large number above 1.3. You could use 10, you could use 20, but 100 is kind of standard. I think the book uses 10,000 if you follow along in the textbook. You should get the same values when you enter these. The calculator is going to be a little bit more accurate though, compared to what we do in by hand. So that's how you do it on the calculator. All right, let's see where we're at. 4 minutes. Okay. This is just IQs being normally distributed. Calculate what percent of scores are above a 130. Working backwards. In this problem, we don't have time for this problem either. The heaviest 2% of candy bars. So it's the top 2%. So that's working backwards. So I'll explain that using, and this one, Rafael Nadal. Please watch the video. I'm running out of time. So on the video, I talk about Rafael Nadal and how he can score. So if you ever see the top, it's the top 10%. I'm in the top 10% of my class. So what does that mean? That means the 90th percentile. Another one is top 1%. Top 1%. That's the 99th percentile. Or the heaviest, like in the last question, heaviest 2%. That's the 98th percentile. All right, so we have all of those percentiles. All right. But like I said, watch the video to figure out how to work backwards doing the inverse function. What speed represents the top 10%? So that's x. So we got to work backwards to find x. And the last thing is calculating a probability plot. So if you're given a data is approximately normally distributed, then we can use normal distribution. But if we don't know, if we're just given data, if it follows a straight line in a normal probability plot, then we say the data is approximately normally distributed. If it's curved at all, if it's curved down or up, then we would say the data is not normal and we cannot use mean and standard deviation. We would have to use median. So here's an example. We have shark lengths is the data approximately normal? So we enter the data into a list in a calculator and then make a normal probability plot. So I'm going to do that for the data that's we already have in there. Press second y equals. Press second y equals. Press enter. And go to on. Press on. Press enter. And go to the last graph. The last graph is a normal probability plot. Press enter. And then all the other stuff, data list should be list 1. Data axis is X. All we got to do is press zoom 9. Zoom 9. And I get a bunch of dots. And the dots follow somewhat of a straight line. If they follow somewhat of a straight line, there's one dot that's way off. That's 11. Make sure, oh, never mind. There we go. I had a 2 in there for some reason. They follow a straight line. So I would say the data is normally distributed for that data set. So I would just enter the data into a list and do a normal probability plot. That's the last thing that you'll see when you're in 2.2. Again, keep up with the reading. I know there's a lot of reading involved. Just read through the examples. So this will sink in a little bit more. I think I made the assignment due by Wednesday. And then we have a chapter 2 test coming up. I'm probably not going to make that due until like Friday night next week. Not this Friday, but next Friday. So you have time over the weekend. You have time Monday. You have time Tuesday or Wednesday to do your work for chapter 2, section 2. And then you can do the test, the chapter 2 test. So again, go take a look at that video about the tennis serving. So it's like 5-minute video, and I posted it on the announcement inside our class on Canvas. So that's the last thing that I really want you to see because it has you work backwards. Okay. All right. Have a great day, and I'll see you next week. If you have questions, my office hours, I'm here Thursday and Friday from 1:50 to 3:10. And in fact, you can go onto this class at any time, and I get an email. And on my email, it says that you are on the Zoom class meeting. So then I just click on it. I check my email pretty often. So if you just open it and just wait there or send me an email and say, I need some help, then go on at that time. All right, any questions? All right, thanks for coming. Have a great weekend. Good luck with everything, and I'll see you next time. Adios.
Bye.